So this is my solar system, and I'm able to use drill press, an air compressor, um, with a few solar panels, redneck system, and 10 bad batteries and 2 good batteries. And so one thing that I'm noticing is with right now I just have one battery connected. This inverter is just connected to that first battery, which is this one here. Right now this battery isn't connected to any other batteries. So what's happened is that it's you'll see that the charge controllers aren't producing any amperage because the battery is at the voltage that I set it to, 14.7. So you'll see that I set it to 14.7. So once it reaches the preset voltage, it'll stop. It'll automatically, the charge controllers will automatically stop stop charging the batteries because they're full. Which leads me to a hypothesis. So what happens when you have a bunch of batteries, like I have? I've got 12 batteries, right? 16 batteries. 3 times 3, 9, 10, 11. 11 batteries. So what happens is, and I've got 10 solar panels of 260 watts each. But what happens is before I just had one solar charge controller. And obviously if you have a little solar charge controller, that's only 400 watts, you're not going to be able to ever fully charge 11 batteries, 11 big batteries. So this leads me to an interesting concept. If I just have one battery like I have now, it'll be able to reach full charge, and then if I have a load, if I run the inverter from it, is that going to be better than if I have the 10 batteries or 11 batteries, but without ever reaching a full charge? So before, when I just had the one charge controller, even though I didn't use anything, any power, any loads, nothing, for days, the batteries would never actually reach anywhere near the 14.7 volts. I think they only got to about 12.5, I think. Even though you're putting 14 volts in at, let's say, 20 amps, that's the maximum each charge controller can handle, they would never actually be able to fully charge. So then what I did is I got another 2 solar charge controllers. This one's a 600 watt one. So now 600 plus 400 plus 400, that's 1200 watts. And still the same 11 batteries. And the voltage at the batteries actually reached 14.1 volts. So it still charged them a lot more, but it still doesn't have enough power to fully charge the bank. And let me just say that again, because this is really important. What the conclusion that I've drawn here is that you need to have an adequate number of charge controllers in order to fully charge a battery bank. So the batteries might actually not ever be fully charged because you don't have enough input power to charge them. And this is the same as using a regular car electric battery charger. You can't have a little charger trying to charge a giant battery bank. It's not going to work. So that's going to lead me to a second test. And what happens is, when I'm running a compressor, when I'm running a big tool, the idea is that it'll run from the solar and not really drain the battery. Now, obviously, I might be... So, let's say I have, just for an example here, let's say I have 1 million watts from the solar system. Even if I just have one battery, and here's the thing that people don't get. The batteries aren't really important for the solar system. And well, that's kind of the test we're going to run here. But if you have 1 million watts from your solar panels, you're not going to need a huge amount of battery. You just need one battery, and then the idea is to run the loads, the tools, from the solar power, not the battery. The batteries only come into play when you don't have any sunlight. So at night, you have to run the batteries if you want to run anything, because you don't have any solar power. But my objective here is I don't really work at night. I just really work during the day here. So I'm not really going to be running a compressor at night. It is to run it during the day when there's solar charge. And that, if that theory works, if that theory is proper, then what's going to happen is that means I don't really need a lot of batteries. And right now, I just have two good batteries that are AGM, not solar, nothing special about them, and a whole bunch of 9 to be exact, car batteries that are old and have been partially frozen in winter, and I don't really know if they're any good. I know that some of them are bad. The ones that have an X on them, and this one says shit. I know that they're bad. Maybe I should even remove this one. But it doesn't really matter because I'm just running the system from the solar. So what I'm going to do in this test is I'm just going to run the inverter from a single battery that's connected to the solar system. So the battery itself is crap, and it's not nearly enough to power on a compressor anyways. But the idea is that the load will be taken from the solar system. And then we'll compare that to having the 10 batteries with the solar system. So I want to see if 1 or 10 batteries, and it's a solar day, it's a sunny day, so I want to see if having 1 battery or 10 batteries makes a difference when you're just running off of the solar. Now there are 2 things with this test that might make it a little less reliable. Number 1 being that I don't know if the solar charge controllers will kick in fast enough to handle the surge current when you turn on a motor. And the other thing is that I don't really have, I might not really have enough overkill wattage. So just like I said before, if you had 1 million, like I had 1,000 solar panels, like in a big solar farm. If I had that much, it shouldn't make a difference if you have 1 battery or 10 batteries, because the solar system is going to handle the load. But in my case, I only have a maximum, and this is if the panels are getting direct sunlight and everything is perfect, which it probably isn't. So I'm using smaller gauge wires. The wires on the charge controllers are 10 gauge or 12 gauge, I'm using 14 gauge. So that might lower the available amperage a little. And the actual output wire to the system is only the 12 gauge. So I'm not sure the 12 gauge wire or the 14 gauge wire, smaller wire, will be able to pass all the amperage or 1,200 watts into the system, into the batteries. So that might make the test unreliable, but we'll test that afterwards as well. So right now, I'm just going to remove the inverter and test it from 1 battery or 10 batteries. So right now I've got all the batteries connected. Everything's connected. Let's run it from the solar here. Let's connect it to the solar. And a few ultra capacitors there too. Not really ultra, but just connect everything. I don't think these clamps here matter too much because the batteries are connected inside there with proper cables anyways. Let's see how much power we can handle here. So let's connect the drill press. The drill press is on. Let's see what's happening with the solar system. This charge controller is not 8 amp. That one only 1.2. And this one's taking most of it, 19 amps. I'm going to be ambitious here. Try to turn on that compressor as well. I think that's too much. But let's just get the drill press running. Run the drill press. And it's currently using 22 amps at so 22 amps at 12 volts. That's what, 2,000 watts? 200 watts. But the voltage is stable, so that means that, see, the battery voltage isn't getting any smaller. It's not draining the battery at all, even though I'm running a pretty, cast iron industrial drill press. See the voltage. There's a voltage drop from there to here. So that's another thing. So we're actually only at 12.5 here. It's almost a volt. But that's still, still not even tickling the batteries. So now, what I'm going to do, I'm going to disconnect and do this test a little bit differently. While the drill press is running, I'm going to disconnect the other battery banks and see if it'll start drawing from the battery instead of just the solar. So one battery bank there. Battery bank there. So 12.3. Actually, hang on. This has to be connected there. Not easy to get this with one hand. 12.3. Drain the battery. But only 12.5 for that first battery. Turn it off and see if it's able to start. Huh, that's funny. So maybe it does need all the batteries, but we don't know if that's because, of course, we had to get a cloud right in the middle of the test. Well, that might just be because see, it's not even being able to turn it on. Let's do that while it's running, see what happens. So if I disconnect, see the amperes put it on. This is kind of confusing, to be honest. Let's disconnect this battery bank. See if it'll draw more from the solar system. I think it should. Yeah, see, it's drawing more amperage now. It's adding more from the solar system. But it looks like the batteries act as like a big capacitor to handle the surge charge. Well, that's my theory. This is a bit of a learning curve here, so we'll end this video here.